Welcome to deletion operation in the priority queue, which is implemented by using the heap data structure. Here, the heap data structure should satisfy the structure property when you are inserting the node, and heap property uh, after inserting the node, right? So heap property is here. I'm using the max heap for creating the priority queue. So max heap is parent node always greater than its child node value. So here first we will extract the maximum element from the root during the deletion operation, then replace the root with the rightmost leaf node in the given heap data structure. Then after deletion we should apply the heap property to maintain the heap data structure. So this is the given elements in the heap. So 16 is available in the root, 14 is the left child, and 3 is the right child, 8 and 10. So here highest priority is heap, root of the heap. So we are going to delete in the priority queue. Actually we will use the priority which are having highest priority will be deleted first. So highest priority in the heap will be root. So we are going to delete the element which is available in the root. So for that what we will do, we will replace the 16 by swapping the 10 and 16 here. So here 16 and 10 are swapped. So once you are swapping, 16 will come into the place of fifth index, 10 is coming into the place of first index. So after that we will remove that 16. We will remove that 16. Our aim is deleting the data. So here we are removing the 16. So after removing, the index will be look like this. So after removing the 6, we have to apply the heap property, heapify process, right? So here the parent node is less than the child value, so that's why we are applying the heap property. So we are swapping the parent and the child. So 14 will become as a parent, 10 is become as a child. Here also 8 is less than the parent value, 3 is also less than the parent value. So now heap property is satisfied. Now we have to remove the next element. We have to delete the next highest element is 14. So now we are going to delete the 14, right? So once you remove the 14, then our data structure is heap data structure is coming like this. So fourth index is also removed now. Then we will apply the heap property again. So when you are applying the heap property again, so we have to swap the child and parent 10 comma 8. So these two have to be swapped. So after swapping, 10 become a parent, 8 become a child. So after swapping, our data structure is looking like this. So here, okay, so 10 is like this, 8 is like this, and 3. So now we have to swap the, so this is not coming here. So now we are going to delete the highest priority is 10. We are going to delete this. So once you want to delete this, we have to swap with the rightmost leaf node. As per the algorithm here, we have to replace or swap the rightmost element. So rightmost element is here 3. Rightmost element is here 3. So with this 3 we are swapping. So 10 becoming a child and 3 becoming a root. After swapping, 3 is in the first index, 10 is at the rightmost index 3. So now we are going to remove this 10. So now we are going to remove this 10. Once you are removing, your data index will be like this. So 3 is at the first index, right? Then 8 is at the second index. After that, again we are applying the heapify process in the priority queue. So heapify process here, parent will become in the larger value, right? And 3 is the lower value, it is becoming as a child. So now again I want to delete the element highest priority is 8 now, so I want to swap, I have to swap this. So 8 will become as a rightmost leaf node, and 3 is becoming as a parent. Now I want to remove this node from the priority queue, highest priority. So after removing, my data structure index will be like this. So now I'm having only single nodes 8, so I'm going to delete the single node also. After removing, my priority queue is empty. So until becoming a empty, if you want to delete, you can keep on delete there. Suppose if you want to delete only one, you can stop with the single element. So this is the way to delete the value from the heap data structure. So here we are passing the number to delete. If you find the number in the array of I by running the for loop, so if you found that, you can break this. After breaking, I mean, after once you break this for loop, it will come here. Once you deleted that particular element, suppose here I want to delete in the given tree, given heap, I am passing the element to delete the 14. Then what I have to do, I have to delete this, then I have to apply the heapify process. So that's why given here we have to make this arrangements based upon the array of I, that what element you are going to delete. If it is greater than the parent node, right, then you have to apply the swapping process by using the heapify. In the heapify, we will check the value with the parent node, child node with the parent value, and right child of the parent, right child with the parent value. Then we will check this, we will swap the numbers based upon the heap property. So to maintain the heap, so here we are having the time complexity for n number of parent nodes. We are going to insert the node and checking the node. So for checking, it is taking the half of the tree, log n height of the tree, so which is finally taking order of n into log n as a time complexity for insertion and deletion, and searching the node in the priority queue using heap data structure. Thanks for watching.